We've had a strong 3.9 magnitude earthquake striking Kansas today. It's just north of Wichita, Kansas, and the central United States has been rocked by this. It's 5 kilometers depth, about 3 miles down, reportedly felt by 39 people, and it's just north of Wichita, Kansas, in the Flint Hills. Now, most of North America, east of the Rocky Mountains, has infrequent earthquakes. Here and there, earthquakes are more numerous. For example, in the Madrid seismic zone centered on southeast Missouri, and the Charlevoix-Kamaturka seismic zone of East Quebec, New England, New York, Philadelphia, Wilmington, Urban Corridor, and elsewhere. But most of the enormous region from the Rockies to the Atlantic can go years without an earthquake large enough to be felt, and several U.S. states have never reported a damaging earthquake. Now, many times we wrote about, I made videos of Kansas earthquakes, and I know that a lot of people have complained that they hear loud booms and shaking under their houses, and we did find that there were at least 11 Kimberlite Diamond-Spewing Volcanoes in Kansas, and there's more being found every few years. So Kansas does have diamond-spewing volcanoes. They're called Kimberlite volcanoes, and they release gas. That's why you hear those booming sounds, okay? Now, earthquakes east of the Rocky Mountains, although less frequent than in the West, are typically felt over a much broader region than earthquakes of similar magnitude on the West Coast. East of the Rockies, an earthquake can be felt over an area more than 10 times larger than a similar magnitude earthquake on the West Coast. It would not be unusual for a magnitude 4 earthquake, as we have here, 3.9, in eastern or central North America, this is our case here, central North America, to be felt by a significant percentage of the population in many communities more than 60 miles from its source. A magnitude 5.5 earthquake in eastern or central North America might be felt much more by much of the population out to a distance of 300 miles from its source. Earthquakes east of the Rockies are centered in population areas and large enough to cause damage, are similarly likely to cause damage out to greater distances than earthquakes of the same magnitude centered in western North America. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Okay, so you can see the frequency here is stopped at the square by USGS. If you extend the frequency lines, I mean, most of the central area has been shaken here. Now, most earthquakes in North America east of the Rockies occur as faulting within bedrock, usually miles deep. Few earthquakes east of the Rockies, though, have been definitely linked to mapped geological faults, in contrast to the situation as at plate boundaries such as California's San Andreas fault system, where scientists can commonly use geologic evidence to identify a fault that has produced a large earthquake that's likely to produce large future earthquakes as well. Scientists who study eastern and central North American earthquakes often work from the hypothesis that modern earthquakes occur as a result of slip on pre-existing faults that were formed in earlier geologic eras and that have been reactivated under the current stress conditions. The bedrock of eastern North America, though, is laced with faults that were active in earlier geologic eras, and few of these faults are known to have been active in the current geologic era. In most areas east of the Rockies, the likelihood of future damaging earthquakes is currently estimated from their frequencies and sizes of instrumentally recorded earthquakes or earthquakes documented in historic records. But we also have man-made earthquakes, induced seismicity, that is. As in the case elsewhere in the world, there's evidence that some central and eastern North American earthquakes have been triggered or caused by human activities that have altered the stress conditions in Earth's crust sufficiently to induce faulting. Activities that have induced felt earthquakes in some geologic environments have included impoundment of water behind the dams, injection of fluid into the Earth's crust, extraction of fluid or gas, and removal of rock in mining or quarrying operations. In much of the eastern and central North America, the number of earthquakes suspected of having been induced is much smaller than the number of natural earthquakes, but in some regions, such as the south central United States of the U.S., a significant majority of recent earthquakes are thought by many seismologists to have been human-induced. Even within areas with many human-induced earthquakes, though, the activity that seems to induce seismicity at one location may be taking place at many other locations without inducing felt earthquakes. In addition, regions with frequent induced earthquakes may also be subject to damaging earthquakes that would have occurred independently of human activity, making a strong scientific case for a causative link between a particular human activity and a particular sequence of earthquakes typically involves special studies devoted specifically to the question. Such investigations usually address the process by which the suspected triggering activity might have significantly altered stresses in the bedrock at the earthquake source, and they commonly address the ways in which the characteristics of the suspected human-triggered earthquakes differ from the characteristics of natural earthquakes in the region. So this is 8 kilometers east-southeast of Asaria, Kansas, north of Wichita in the Flint Hills. All of you there, please be very careful and know that you do have Kimberlite Diamond-Spewing Volcanoes in Kansas. So here we are. This is by Kansas Geological Survey and the Kansas Kimberlite volcanoes. And here they are. 13 kimberlites have been identified so far, 12 in Riley County, 1 in Marshall County. 6 kimberlites are exposed at the surface. The others are buried under soil about 25 feet down. And this circular provides general information about these rare, unusual rocks found in the heartland of the United States. Now, diamonds occur in only 2 rock types on Earth, kimberlites and lamproites, both rare in Kansas. The kimberlite is unique because it originates over 100 miles deep in the Earth and travels at a matter of hours to the Earth's surface, where it forms small volcanic features. In Kansas, kimberlites or kimberlite pipes occur in a restricted northeast trend belt in Riley and Marshall. Here we are. These rocks were first discovered in Kansas in the late 19th century, and since then, more kimberlites have been found, at least 3 in the fall of 1999. Okay, so we have 13 kimberlites right there for you who want to know. Ripley has 12, 6 of them exposed to the surface, and 1 in Marshall. So there you go. Please leave your comments, and thank you for your support.